Assalamualaikum and hi everyone. So in this video we are going to learn about solubility equilibria. At the end of the lesson, you should be able to define solubility, molar solubility and solubility product KSP. Define and explain the common ion effect. This is the process of dissolving of a slightly soluble salt. A slightly soluble salt here means that not all salt will be completely dissolved in water or in any solvent. So one of the example of slightly soluble salt is AgCl, that is silver chloride. So when you put some AgCl in any solvent, let's say in water, it will produce Ag plus and Cl minus. So when the solution becomes saturated, AgCl solid will precipitate out. Saturated here means that the AgCl cannot be dissolved anymore. So here's the equations to show the dissolution of silver chloride. So AgCl in a solid will produce Ag plus in aqueous phase plus Cl minus in aqueous phase. The equilibrium exists when the solution has become saturated. The equilibrium here means that the process of dissolutions and precipitations happens at the same time. When the solution has reached equilibrium, the amount of solute does not change with time. Solubility product constant KSP. In a saturated solution, an equilibrium exists between the solid salt and its dissolved ions. For example, the equilibrium AgCl solid produce Ag plus in aqueous phase plus Cl minus in aqueous phase. So the expressions of solubility product constant KSP is supposed to be the concentrations of product divided by concentrations of reactants. So that means it's supposed to be concentrations of Ag plus times with concentration Cl minus divided by concentrations of AgCl. But the concentration of the solid is constant. So we only include the concentrations of product. So the correct KSP expressions is equal to concentrations Ag plus times with concentrations of Cl minus. Solubility product is the product of the molar concentrations of the ions involved in the equilibrium, each raised to the power of its stoichiometric coefficient in the equilibrium equation. For example, for the general equations Mx2 solid produce M2 plus aqueous plus 2x minus aqueous. So the expressions, the solubility product constant KSP is equal to concentrations M2 plus to the power of 1 times with concentrations of X minus to the power of 2, since the stoichiometric coefficients in the equilibrium equation is 2. The value of KSP is a measure of the solubility of a compound. So here are the selected ionic compounds with its solubility product constant KSP. So as you can see from the first one, aluminum hydroxides, the KSP value is 3 times 10 to the minus 34. But the last one is zinc iodide ion. Zinc iodide compound ions is 3.9 times 10 to the minus 6. So these two ions have different KSP value. So the KSP value will tell you which salt is more soluble and less soluble. So the smaller the KSP value, the less soluble the salt. So from this list, the most soluble salt here is zinc iodide, and the less soluble salt is aluminum hydroxide. Solubility. Solubility is a quantity of solute that dissolve in a given quantity of solvent to form a saturated solution. There are two types of solubility. The first one is mass solubility. Mass solubility is the amount of solute that dissolve in a solvent to produce 1 liter saturated solution. And the unit of mass solubility is gram per liter, or kilogram per dm cube, or gram per dm cube. Molar solubility is the number of mole of solute in 1 liter of a saturated solution, and the unit of molar solubility is mole per liter. And the solubility of a substance depends on the temperature. So if the temperature increases, the solubility of substance will also increase. So here's to summarize the equations of dissociations or dissolutions of salt and its solubility product constant. So if the salt is mx2, the ions that will be produced is m2 plus 2x minus. And the solubility product constant Ksp is equal to concentrations of m2 plus times with concentrations of x minus to the power of 2, because there are 2 mole of x minus. So the molar solubility of the ions is the concentrations of the ions. Write the ion product expressions for saturated solutions of silver chloride in water. So write down the equations of the dissolutions of salt, AgCl, in solid, produce Ag plus aqueous plus Cl minus aqueous. So the ion product expressions here means the Ksp. So the Ksp is equal to Ag plus concentrations of Ag plus times with concentrations of Cl minus. So here's another example to write down the Ksp based on the chemical equation. So the first one is MgF2 will produce Mg2 plus 2F minus. So the Ksp is equal to concentrations Mg2 plus times with concentrations of F minus to the power of 2. The second one is Ag2CO3 will produce 2 mole Ag plus ions and CO3 2 minus ions. So the Ksp is equal to concentrations of Ag plus to the power of 2 times concentrations of CO3 2 minus, and the third one is Ca3PO4 will produce 3 mole of Ca2 plus 2 PO4 3 minus. So the Ksp is equal to concentrations of Ca2 plus to the power of 3 times with concentrations of PO4 3 minus to the power of 2. Consider the following Ksp expressions. So let's say the Ksp expressions is equal to Cu2 plus times concentrations IO3 minus to the power of 2. And which of the following does this equilibrium expressions represent? So from the Ksp expressions, there is 1 mole of Cu2 plus and 2 mole of IO3 minus. So the answer is D.